All right, so let's go over how to find the area of a trapezoid. So a trapezoid, the big difference is that it has two bases. So the trapezoid has two bases, which are made up from the parallel lines that are in the trapezoid. In order to find the area of a trapezoid, we need to add both of the bases together and then multiply by half of the height. That is the same thing as saying divide it by 2. Remember when we're multiplying by 1/2? We're actually dividing by the bottom number. So let's look at the formula. Our formula for a trapezoid is A equals 1/2. Then in parentheses we have B1, which stands for base 1, plus B2, which stands for base 2. Close parentheses, and then your H is on the outside. This formula is very similar to the formula for a triangle, except we now have two bases instead of just one. Let's go ahead and look at the examples we're given and find the area for these trapezoids. All right, so I'm going to refresh our brain by writing down the area formula again. So area equals 1/2 B1 plus B2 times H. So it's the same formula I'm getting off of my reference chart. And that's the same one I'm going to use for every single trapezoid I see. So again, we have two bases. These are those parallel lines that we see, and they're marked out well for us. We don't have any useless information here. These are our bases. They're run parallel, they will never touch each other. And again, our height is shown by this dotted line in the middle of our shape. Since I've already written my equation, I'm going to go ahead and fill in the pieces of information. So I would write this as area equals 1/2, and in parentheses I'm going to put my two bases before I add them together. 18 plus 10, close parentheses, and then I'm going to put my height at the very end, 14. So what I'm going to do is I'm going to follow this, I'm going to solve this following order of operations, or PEMDAS. So obviously the first thing I need to do is the parentheses. So my 1/2 stays out here, and I'm going to do 18 plus 10. That gives me 28, and 14 stays on the outside. So you can either multiply or divide by 2 to the 28 next, or to the 14. It is up to you which one you would like to do. Whichever one looks easier, whichever one makes your numbers easier to work with, that is perfectly fine. So I chose to do the division, or the 1/2 of 28. So area equals half of 28 is 14, and I'm left with just multiplying by what's at the end, my height, which is also 14. This leaves me, once I multiply this all the way out, I get 196 as my number. And to put in my measurement unit, we have meters squared. The reason it's still squared, even though we use 3 numbers, is because we are still working with a base and a height. We're not talking about any other form of measurement. Let's move on and look at this second example here. So we have another wonderful example here. We have that height, which I can tell is there from the dotted line of 8 meters. And then that shows me what two bases I have. So I have 6 meters and 12 meters here. Again, I'm going to go ahead and fill in my equation with my base information. So I'm going to start out with area equals 1/2. So I need the values of my two bases, 6 plus 12. Close my parentheses, and then the 8 hangs out at the end until I'm ready to use it. Again, the first thing we're going to do is add what's in the parentheses together. So we're going to have area equals 1/2. 6 plus 12 gives me 18. and 8 stays in the back. I'm going to choose to make my 18 smaller, so I'm going to divide that by 2, and that gives me 9. And then don't forget that 8 at the back where we still have to multiply those together. My last and final step is 9 times 8. That gives me a total of 72. And again, our measurement is in meters, and since it is still area, it stays squared. Now let's go ahead and look at this last example. Over here, we have 16 meters, 6 meters, and 12 meters. So again, my two bases, I have 16 meters and 22 meters. And then I have my height, which is 6 meters, again shown by that dotted line. I'm going to go ahead and fill in my information into the area formula for a trapezoid. So area equals 1/2. I'm going to add my two bases together, so 16 plus 22, and then 6 goes on the outside. Follow order of operations, so I'm going to go ahead and I'm going to do 16 plus 22. So I'm going to leave my 1/2. 16 plus 22 gives me 38, and then the 6 at the end. Personally, in this situation, I think it would actually be easier to divide the 6 by 2 to give me smaller and easier numbers to work with. So I'm going to go ahead and do that. Honestly, it doesn't matter which one you divide by 2 as long as it is divisible by 2 and works out to be a nice pretty number, unless you're working with decimals, of course. So I'm going to go ahead and divide the 6 by 2. That leaves my 38 first, and 6 divided by 2 is 3. I find that this is much easier to use with multiplication. And then I will find, once I multiply that out, that the area would be 114. And again, this is in meters squared because we're still finding area and the measurement type is meters. Again, this is very similar to triangles. The only difference is now we're having to add both of the bases in order to make up for that base. So once we get basically to this step here, we're back to a triangle formula, and we're just working through that. The only difference is that addition of the two bases. Let's go ahead and look at this word problem and see how far we can get into it. So this word problem says, solve. A trapezoid has an area of 150 square meters. If the bases are 14 meters and 16 meters, what is the height of the trapezoid? So first of all, let's read through it. We've already read through it, but we need to find what was important here. So the first thing that I see is that the trapezoid, always again, that's very important. What shape you're working with tells you what formula you're going to use. Has an area of 150 square meters. So we need to know the area. The next thing it tells us is the bases. So we have a base of 14 and 16. So those are the two bases that we would have. The question asks us, what is the height of that trapezoid? So area is 150, base is 14 and 16, and we need to know the height. So just to help me visualize this, I'm going to go ahead and draw this little picture. Is it perfect? No. Do I care? No. I know that the whole thing is 150. Oops. I know that the bases are 14 and 16, so I'm going to label those. And what we don't know is that height. Is that line right here connecting them. But we do know that the total is 150 meters squared. So, using this information, we're still going to use that formula. A equals 1/2 base 1 plus base 2 times the height. So let's plug in the information we have. I don't need to write the A because I already have the A. That's the area. 150 equals 1/2, and then we need the bases, so 14 plus 16. We are left with H at the back. we would first need to add and then divide by 2 before we could even move anything away from that h. So 14 plus 16 gives me 30. So 150, 1/2, and 30. I need to simplify this first. 100 or 1/2 of 30, or 30 divided by 2, would give me 15. Now I'm down to something that I can do one last move and get that variable all by itself. That would be to divide by 15. The reason why is because I need to get that h all by itself. So if I was to do 150 divided by 15, that would give me the answer of 10 as h. So what that means is that it's 10 meters as the height for the trapezoid. Remember, the biggest difference with trapezoids is that you have 2 bases versus 1 as compared to a triangle. Do not forget that that 1/2 technically means that you're multiplying because it's touching, but a fraction means divide. So you technically are just dividing by the number on the bottom.